So yesterday we saw the process called Prastara, right? And Prastara, as we saw, it is also the process and name for the process, right? So we saw this. We saw the building blocks of Sanskrit meters, which is syllables. And then we saw this same structure in verses. We saw something called as ganas, 8 ganas, in two different ways of remembering the arrangement, the pattern in each gana. One is this Adi Madhya Avasaneshu, the other is using the mnemonic Yamata Rajabhana Salagam. And we saw that when we replace the laghus with 1 and gurus with 0, we get something called as a de Bruijn cycle, with which we can generate all binary sequences of length 3. Then we saw that in the chapter 8, we have a chapter 8 of Chandas. We have 6 operations, so to say, that are being explained. So one is Prastara. It's a rule with which you can write down all possible meters. You can do the listing. Second is Sankhya. Sankhya is the process of finding power of a number. In this case, 2. Now we go to the third process, that is Nashta. Okay, Nashta, as the word suggests, and in most languages in India, Nash or Nashta or Nashtam, it means, what does it mean?
Loss.
Loss, right? Something lost, something, some destruction happened or whatever. So the idea is, suppose you list a Prastara and the wind blew and it blew it away. Okay, so what does that mean? Because in the past they were writing on the ground, on sand and everything. Let's say there was a lot of wind, or maybe on the beach, and the waves took it away. So what you have is, you have certain arrangement. You had started from GGG and written, but then unfortunately this part is gone, and now you have a GLL. Okay, now you want to know which row does this GLL come in. One way to find out is list everything down and then find out which row GLL will come. But that will be a very taxing process, no? Because you have to list everything, and imagine that yesterday's example of 100 Gs. So if you want to find out where will GLL, GGL, GG, so something like that, where will that appear? It's going to take up a lot of time. So can we find that particular thing? So Nashta is the process of finding any row with, Nashta is where it is blown away and you want to find a particular row number. Let's say you want to find the 7th row. Okay, it is blown away and you want to find the 7th row. How will you find the 7th row? And Uddishta is the process that I just said. Sorry, I just mixed them up. Uddishta is, everything is lost, and then you have a particular arrangement and you want to find out that will come in which pattern, which row number. Okay, that is Nashta and Uddishta. Okay, so we'll see Nashta and Uddishta in this. So we have Sankhya and Nashta. Okay, so the sutra that was given, like I said, the entire Chandas is written in sutra style. The sutras are very cryptic. It is not easy even for Sanskrit Pandits to decode it unless and until they have a good background of Sanskrit as well as mathematics, as well as understanding these subjects. So this goes something like Lardhe, Saikeg. So that's it. What is this Lardhe? This is La. Okay, and Sa, Ik, G. Okay. Now to find the metric pattern of a row of a Prastara, start with the row number. Suppose we have a 4-syllable Prastara. We have a 4-syllable prastara. What are we trying to find? A particular row number will come, or what will be the metric pattern in a particular row number. So let's say in a 4-syllable prastara, we want to find the 13th row. Okay, 13th row. Okay. So we want to find the 13th row. What do? This is what we need to do. Half it if possible. That is half 13 if possible. Now 13 cannot be half as in, you will get a remainder. So if it cannot be half, add 1 and half it and write G. Okay. So we will take 13 cannot be half. You add 1. Okay. Add 1 and half it. So we get 7. So when you are doing this, write a G. And then it says repeat the process until all the syllables of the meter are found. So we are talking about a 4-syllable prastara and or 4-syllable vritta. Vritta is the meter, prastara is the listing. So 4-syllable prastara, that means we need to fill in 4 spaces. You got 7 now. Again ask, can 7 be half? No. If it cannot be half, then what we do is we add 1. That is 7 plus 1 divided by 2. We get 4. When we add 1 and half it, you place a G. Again ask, 4 can it be half? Divided by 2, which is 2. So when it can be half, you place a L. And 2, when it can be half, you place a L. You can check, is the 13th row Guru Guru Lagu Lagu?
Yes, sir.
All of you have the list?
Yes, sir. It's correct.
It's correct, right?
Yes, sir. It is correct.
It's correct. Any questions? What question comes to your mind?
So why does it work?
Exactly. Why does it?
Why does it work? Okay. Any other question?
Yes, sir.
Yes, go ahead.
So, for example, we took the 13th row of a 4-syllable prastara in this case. What if we need to find the 13th row of a 5-syllable prastara?
Good one. What if we have to find 13th row of a 5-syllable prastara? Can somebody comment on that? Anushka?
Sir, I think we are left with 1, so we'll again add 1 and divide by 2, and again we'll get 1.
Right.
So that would mean an L. Okay.
Yeah, that's what I think.
Advait, does that make sense?
Yes, sir.
And if
So-
you
so
look
that-
at it,
Does that mean for
just 1 second, just 1 second. So you take G, 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 all the way up to L, 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 right? You have 16 possibilities. And if you remember, this 16 possibilities are copied and pasted down, and you have all G, 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 right? Or you have all L, 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 L. What do you write first? G, 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 right? G, 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 G,
Yes, sir.
and then you have L, 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 L. So is this correct? This is G, no? This should be G. Because if it cannot be half, we are adding 1 and writing a G. So the last one has to be a G. Last one is a G. Now if you look at the 13th row, 13th will come somewhere over here, right? In a 4-syllable, this is correct. And then we are placing a Guru at the end, right? When we do that algorithm of Pingala.
so does it mean like for example 6-syllable prastara anything, it would be again a G G G because
Yeah.
we can't go
Yeah.
anything after 1.
The moment you reach 1, you can put all G's after that. It's as simple as
Yeah.
that. What other question comes to your mind? This is one question. Why does it work?
So this is sort of similar to the other one we saw before. Like, is there any connection?
Is there any connection?
Like the one where we saw 0 and we added a 2 and all that stuff.
Yeah. Is this connected to which one? The Sankhya, right? Sankhya. Connected to Sankhya. What other question comes here now? These questions should come to our mind when we are doing math. Okay, we solve the problem. No, what can we think about? Let's take a step back and think. What are some important questions that we should be thinking about?
So what if we take a row number that does not exist?
What do you think will happen?
I think we won't reach 1.
We'll get a 5-digit, like till we reach 1, we get a 5-digit or like another 1 more digit. If we
Let's
take
take
say 18, yeah,
18.
we get a 5-digit.
Divided by 2 is 9. Divided by 2 means we took put a L. Plus
Then-
1 divided by 2. We get a 5. G. Plus 1
Again-
divided by 2.
Again a G.
And then
Again a
plus
G.
1 divided
Again a
by
G.
2. This is G.
So we
sorry,
stop
this-
at G, right? Because we're looking for 4 syllable.
Right.
And-
But the problem is 18th row does not exist in a 4-syllable prastara.
Yeah.
We'd have to complete till 1.
Yeah. And if you
So-
recollect,
so-
if it is if it's 4-syllable prastara, we have 16 possibilities. Anything more than 8 will end with L. 9th row onwards will end with L, right? So it definitely cannot end with G because it is 18 and we know 16 divided by 2 is 8. Anything more than 9 should end with L. Kirti?
Sir, this is the second row, sir. It is like modular arithmetic, I guess.
Yeah, I was gonna say that.
Oh,
We can take that 18th mod 16 if it is greater than 16, and
Yeah.
otherwise if we consider the 5-digit, then it will become G. But if we want to find 4-digit, we'll take that number mod the number of ways we can arrange the 4-digit syllables.
interesting. I never thought about it, honestly speaking. So this one is when you say 18, you are indirectly referring to the second row, perhaps, because it goes in a
Yes.
cycle. Okay.
Yeah.
Nobody is getting this question. How did he even come about this? What was the idea that prompted him to get here, right? How did Pingala come up with this? Because there are two things. One is this is the proof part, right? Why does it work? And we have different tools with which we can prove things, techniques for proofs, methods of proofs. But how do you come up with something very original? Do we have a method for this? How do we come up with something that nobody has thought of till now? Right? And that is a great quality. I mean, if we can do that, because you'll find a lot of people who have this ability to prove. So amongst you also, you will see that a lot of people, okay, you want to prove this? Yes, I take out a lot of tools from my quiver and say, okay, maybe this will work or this will work. You have a lot of tools. How do you come up with something very original? Right? And that demands a lot of creativity. That is what?
I discussed this. Right?
Yeah. And it is that creativity that we should really think when we look into history of mathematics. Not just Indian mathematics, history of any civilization's mathematics. How did they come up? Oh, you're like, wow, how could people even think about that? Anushka?
So maybe we can try to work backwards from the result and try to understand how he applied logic to each of the steps to see where he came from and what was his reasoning.
Yes, it's similar to what Haim did yesterday.
Yeah.
What proving that.
right? So we should definitely try to think, and maybe that is one plausible way, okay, one plausible way in which Pingala would have thought, right? So do you want to do one more exercise? Let's do, just to get our just to get a better hands on. Let's take maybe 23rd row of a 5-syllable prastara. 23rd row of a 5-syllable prastara, and let's take 52nd row. Okay, 52nd row of a 7-syllable prastara. While you are doing this, if anybody has any questions in this, I'll try to address them.
So shall we send it to you or put it in the chat to everyone?
Yeah, you can send it to me. Most of you have completed the first one. Let me write it.
So complete the second one.
23rd row, right? 23rd row of 5 syllables. So 23. Let me just call out somebody. You can help. Jonathan, tell me, how do we start?
So since we can't divide by 2, we're supposed to add 1 and divide by 2.
Hmm.
And then write a G. Then since this is divisible by 2, we can write an L. And again another L since again it is divisible.
Mhm.
Now it is not divisible, so we add 1 and divide by 2. And now since this is divisible by 2, we write another G.
Are you sure?
Sorry, L.
So this will be the 23rd row. Next one is 52nd row of 5 syllables. 52nd row of 5 syllables.
7 syllables.
So 7
Seven syllable.
Seven. Sorry, Indraneel, can you help me with that? 52nd row of 7 syllables. Indraneel. Yeah. Can you help me with that, Indraneel? Are you there, Indraneel? Can't hear you. Jatin, can you help me with the 52nd row?
Oh, yeah, sure. 52 is divisible by 2, so you get 26 and you write L.
Yeah.
26 is divisible by 2, so you write 13 and you write L.
Mhm.
Then you add 1 to 13, divide by 2, you get 7, you write G.
Mhm.
Then you add 1 to 7, divide by 2, you get 4 and you write G.
Mhm.
Then you write L because 4 is divisible by 2.
Mhm.
Divide 2 by 2 again, you get 1, write L.
Mhm.
Then add 1 to 1 and then divide by 2 and you write L.
We get, I think this
Sir,
is
the
what.
last one is G.
Last one's G.
Oh, sorry, yeah,
Ah,
G.
right. Okay. All right. So Ishan made a comment in the chat. Ishan, can you unmute? Before we started doing this. Yeah.
So I try to think of the patterns as binary numbers, but
Mhm.
the sixth binary number, like that way, comes out to be 10, but it should be 6, so it doesn't work. Or maybe it works and we're looking at it wrong way. I'll think about it more.
Okay. So the idea that Ishan is suggesting is you convert L and G to a binary number. Okay. And Advait was asking, should we take a 1 for L and 0 for G? And should we do something on that? And then maybe Anushka, wait 1 second. And then see if there is a connection between binary numbers and this one. And Ishan tried. The numbers didn't match. So Ishan seems to be a little disappointed. Anushka, do you have a reason why the numbers don't match?
So actually,
No,
we
it's
should
a
take.
yes or wait. It's a yes or no question. Do you have a reason why the numbers don't match?
Yeah.
Okay, don't say it. Okay,
Yes,
so
even I have a reason.
okay, so now I want others to think why the numbers don't match and can we match it in some way. So the idea is definitely binary. The idea is binary. And why is it not matching with the, so I hope everybody understood what is meant by matching here. So this is 1000, which refers to the number 8. Okay, it refers to the number 8, but if you look at GG, this is the second row, so it is not matching with the second row. So we will why is it not matching or what can be done is something that we can think about. We'll not discuss it right now. We can discuss it during the help session. Kritika, is that a question or is that an answer?
Answer.
No. So you can lower your hands, Anushka and Kritika. We'll move on to Uddishta process. Okay, so this is Nashta, we know. Uddishta. So Uddishta is, oops. Okay, let's take Uddishta. Uddishta is to find the row number of a given metric pattern, scan the pattern from the right. Which means if you are having G, L, 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 let us say, scan the pattern from the right. What is Uddishta? Uddishta is we have a pattern, we want to find the row
It's
number.
something like the opposite of that one.
Right,
the
opposite
process.
of Nashta.
Opposite of Nashta.
So you start with 1 and scan from the right. Scan from the right. You start with 1. Double when an L is encountered. Okay. Pratiloma gunam. Pratiloma ganam. Dvi is twice. La is lagu. Ardhyam. La Ardhyam. Okay. This is Ardhyam. Ardhyam is first or 1. So you start with 1. Probably that's what is being said. Tato ekam. This is Ga will refer to Guru. Ekam is 1. Jahyat probably is reduced. Tad is that. Okay. So reduce that by 1. Pratiloma Mm, Ganam. Ganam is probably a number. So I'll have to think about what does this mean. Okay, never mind. So we will go here and start scanning from the right. Start with the number. Double it when an L is encountered. So you start with 1. You see a L, you double 1, you get 2. You see a L, you double 2, you get 4. You see a L, you double, you get 8. You see a G, double and reduce by 1. So double it and reduce by 1, you get 15. We need to check, is this the 15th row of a 4-syllable prasthana? And we don't have to check, we can just check what is the next row. It has to be
Yeah.
L, 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 L,
L.
right? So this has to be the 15th row. Okay.
Yes.
Again, natural questions are, why does it work? So if you find out the reason for nashta, we will be able to find out why uddishta works, or the other way around.
Trying the converse of each other.
Yeah, yeah. Okay.
So this is basically the opposite of the other process.
Yes, the opposite of the other process. Yeah. Ishan, I saw your comment. Yes, that's correct. So this is uddishta. I'm just going to skip a few slides. Maybe there are. Okay, so this is another way of uddishta. Okay, suppose you want to find which row this comes. What you do is you write powers of 2 below the numbers 1, 2, 4, 8. Numbers below L are 2. Right? Numbers below L are 2 and 8. Add both of them. 2 plus 8, you get 10. And add 1 to it. That is a blanket rule. You do that. You get 11. So you will see that Guru Laghu will be the 11th row. It's as if he has got a magic hat and he's pulling out stuff from the hat. Take this method. You take another one. Kirti, question?
Yes, sir. In the
Mhm.
method, you explained that we have to start scanning from the right, but then why have they scanned from the left?
This is another method.
Okay.
This is a different method. So in the other method, you scan from the right and then you do this. Start from 1. When you see a L, you double it. When you see a G, you double and reduce 1. Here we are scanning from the left and doing it. Okay. Ritin?
Sir, why are we just using L here and not using G?
That is what. So once we see what is the reason behind this, I don't know if you guys have seen the movie Matrix, very old movie. So Matrix, it's a Hollywood movie. So in that, the hero, you should see that movie to understand. Finally, he understands the world in terms of binary, and then he says that, wow, now I know why things function in this way. So he has kind of decoded the entire formula of why things work. So here also, once you decode why one of the processes is working, you will be able to connect that and figure out why the others are working. We can discuss that during the help session. I just don't want to spend time right now on that. Until then, you can also think. Meera, question?
Yeah, if we found out how this method works, then can we find that how the other two methods work too?
Maybe. Devanand.
Sir, in this case, we added up 2 and 8 since it.
Wait. Are you asking a question or you want to give the answer?
Sir, doubt, sir.
Doubt. Yes. Go ahead.
Sir, here we are adding 2 and 8 since it is below L. But why are we adding 1? Is it just?
Why are we adding 1?
Yes, sir. Is it since it is written below the 1?
No.
Okay.
Well, add 1 is a blanket rule. It's a compulsory rule. Why should we do that? Is something that you will realize when you know why this is working. Oh, that is why we add 1. You will get that, aha moment once you are able to see that. Once you are able to see why it works.
Okay, sir.
Mridula, question?
Yes, sir. Sir,
Mhm.
does this L rule work even if there are more or lesser L's? Like even if there is one L, we add one and get the row number.
Suppose we have all G's, no L. So what do we do? No L. So just add one, and this is the first row. We have one L. There is one L. This is 1, 2, 4, 8, 16. You add 1 to 16, you get 17. This will be the 17th row.
Okay, sir.
Bhageshri, question?
So why we have to only add up the number below the L? Why we can't add the number below G?
So that's what I was saying. Once we understand why these methods are working, we will be able to figure out, oh, that is why we are taking numbers below L and not something else. Okay. इसका जब लॉजिक समझेंगे हम लोग तभी हमको समझ में आएगा अच्छा L के नीचे वाला नंबर ही क्यों लिया हमने, G के नीचे वाला नंबर क्यों नहीं लिया. But for that we need to understand this logic. So what I'm expecting from you is you'll spend some time thinking about it, and then we can discuss that in the help session. Some of you have understood it. You have sent me the reasons on private chat. Reminds you of induction. Yes, Mira, these are excellent problems where we can use induction and things like that. I don't know whether directly on this problem, but you will see problems like these, right? Because it follows patterns and all that. Okay. Mira, question?
Sir, I just want to ask that in the previous method, we added like in the Pingala's method of Udishta, then we added 1 and then we halved it by 2 and then we wrote a G, right? And in L, we only divided it by 2. Here also, we are taking the multiples of, here we are taking the powers of 2 only for L, and I think it is for the whole G that we are adding 1.
Okay, we will see.
Yeah.
All right. So this is an observation that both Nashta and Uddishta processes of Pingala are essentially based on the fact that every natural number can be written as a unique binary representation. That means there is a unique binary representation for every natural number. You will say, what's there in it? It's so obvious that any number you take, suppose you take 285, of course there will be a binary representation for this. You take 613, there will be a binary representation of this, and that will be unique. But then it is not that obvious. It is not that obvious because, or at least it is obvious to us now because we are standing on the, as Google Scholar says, standing on the shoulder of giants. If you look in Google Scholar, their tagline is like standing on the shoulder of giants. What does that mean? Because a lot of people have already contributed, we are able to contribute more. Right? So this might be obvious to us because we know a lot of things that somebody has done. But the essential principle that is being used here is this. Then it can be uniquely represented as sum of different sankhyas or powers of, not powers of 2 power n, it should be powers of 2. Okay. Coming to something called as Laga Kriya, will not be spending time over here. So this is the sutra, Pare Purnamiti. What is this Pare Purnamiti? It says
Purna means end.
So this is the commentary or explanation given by somebody named Halayudha, who was a 10th century commentator. You can see after 1300 years, somebody is writing. Not that he was the first person to write after 1300 years. There may have been other people who wrote commentaries. So commentaries essentially is another feature of Indian mathematics. The text would be written like this, which very few people on planet Earth can actually decipher. So you need somebody who can explain this in a better way, and those would be commentators. So these commentators would would write detailed commentary. So as you can see, this is quite detailed, right? For 2 words, Pare Purnamiti. What does that even mean? Right? So this is the explanation that is given. And sometimes even this explanation is very hard to decipher. So there would be commentary of a commentary. Okay, that is, the commentary itself is challenging to understand. So we have a commentary of a commentary. And I have seen something which is a commentary of a commentary of a commentary of a commentary of a text. And of course, to understand that also, we had to have some scholar who explained it to us. So it is not that trivial or easy. All right. So this, what does this give? It actually gives you something called as Varnameru. That Lagakriya is giving you the instruction of constructing this. I'm sure many of you would have seen this, right? This
The
is what
Pascal
we
triangle.
famously called
Yeah.
as the Pascal's triangle, right? Which
And
we
the
attribute
statement
it
is
to.
Pascal's identity.
So there was this French mathematician by the name Blaise Pascal, who came up with this idea, maybe independently, or maybe he was the one who popularized the idea. So the Western world knows this as Pascal's triangle. But about 2000 years before Pascal was our dear friend Pingala, just 2000 years back. 2000. When I saw the first time, I was so awestruck. I said that how can something be discovered 2000 years before, and especially in a topic like permutations and combinations. See, so it gives this particular triangle. We will not get into the discussion on what is a Pascal's triangle or Miru, right now, but this is for your information. And why this identity? Because this procedure that he is giving here is based on this. So he says, if you want to get this cell, then you should add these two to get the next one. To get the next row, you should do this. To get, you start with one and then you add these two, you get the next row. You add these two, that is the procedure he is giving. So when he is giving that procedure, he is essentially giving this particular identity. Okay, or he is using this particular identity, right? So people have started calling this as Varnamiru, and Varna here refers to color. Okay, and color is 2 colors of syllables or 2 types of syllables. Color, again, what is in Indian context, they were not using variables like X and Y or A and K, as variables. They were using colors, blue, red, as variables. Okay, 3 blue, 1 brown would be something like 3x plus 1y, something like that. Okay, so Varnamiru is just the rotated version of the Pascal's triangle, which was given around this time period. And if you rotate it, you will see, oh, this is what we see in a horizontal view. So comments. Pingala was the great originator of all the binary mathematics, and it was rediscovered somewhere in 1990s. Sankhya algorithm is one of the most efficient algorithms for finding nth power of a number. This algorithm of Pingala became the standard algorithm for computing the nth power of a number. Until a few centuries ago, this was the standard algorithm. Before computers and everything came into existence, most parts of the world, they were using this algorithm to find nth power of a number. Okay, and this is a short history of development of Chandas, permutations and combinations. Pingala we see 300 BC. Then there is Bharata, who wrote Natya Shastra, Bharata Muni, Bharatanatyam that you would have heard, 100 BCE. In that also, they explain permutations and combinations. And then Brahmasputa Siddhanta, in that also we see combinatorics. Virahanka's work, Vritta Jati Samuchaya, that also we see combinatorics. Mahavira's Ganita Sarasangra, it's a mathematical text. There also we see combinatorics. Halayudha, commentary on Chandas, again. Kedarabhatta Vritta Ratnagara, 14th century. Again, 1000, 2000, 1300, I mean 1200, 1300. So this is just to show how there was a perfect lineage of work. And this is what we call as research. No, research is not what I independently discover. I am able to discover because somebody else has worked on something and I'm just taking it forward, or I'm adding my piece of the jigsaw puzzle over there. And people have already put in a lot of things. So in research, what we do, we refer to what has been done in the past and we are extending it further. And we can see that clearly in the Indian context. So research is not a modern thing, it was existing, and in different disciplines we can see that. Okay, so these are a few sources. This is a very good course available on NPTEL. It's there on YouTube. If you look at history and development of mathematics from Vedic period to modern times, it's a 40 lecture course. And this was a course that Hariharan sir, I, and some of you may know one of the alumni, Raghavendra Bhatt. I think he also is going to deliver a session here. So he, Hari, I, a few of us, we had attended this course long back in IIT Madras when this video recording was happening. So if you see those video, you will see younger versions of us in that video. A few other things. Okay. All right. So this is the Pingala's part. Okay. Now we will see what happened after Pingala's time. Right? It did not end there. So how it was taken ahead. But before that, if you have any questions in mind, some quick questions that you want to ask, I'll be happy to take questions. Few questions that we have that is open, and you may want to write this in case you haven't. Why do all these techniques work? Right? This is something that you may want to think about. How did Pingala come up with these ideas? And maybe if you get one connection, from there you can build other connections. Oh, that is how he did Nashta. Oh, that is how he did Uddishta. Oh, that is why this thing works. Okay. So you'll have to find that first connection. Right? Okay. And I've already given a clue that it is related to binary mathematics. Now we go to something called as Matra Vritta. Vritta is again, Vritta has got different meanings. Vrittam means circle. Vritta also means verses or lines. So Matra Vritta, the earlier was Varna Vritta. Varna is where we are using a certain count. Okay, so if you are having G, L, G, L, we are saying we need, this is 4 syllables in a vritta, in a line, 4 syllables in a line. So we fix the number of syllables in a line. It is very important. Pay attention. And can you all switch on your videos? I really don't mind if you are not looking fresh or something. Just keep your videos on. So in Varna Vritta, we are keeping the number of syllables fixed. But in Matra Vritta, the number of syllables can change. What we do is we assign values to Guru and Laghu. So Guru refers to 2 and Laghu refers to 1. in Matra Vrata. Okay, so we are giving some value and we are trying to find, if we want to find or if we want to write Vrata whose total count is 6, then in how many ways we can do? You can write a GGG, or you can write a LLGG, or you can write a LGLG, or you can write a GLLG, right? Because this is 2, 2, 2, 1, 1, 2, 2, 1, 2, 1, 2. So what is the mathematical problem that we are trying to address? Can somebody raise hand? I'll call out your name. What is the mathematical problem that we are trying to address? Just do a raise hand. Let everybody think. I'll wait for about 30 seconds. Advait?
Yes, sir. So we are just taking the sum of the values which are assigned to G and L respectively.
Okay, so how would you state the mathematical problem? If you want to frame a question, how will you frame that question?
If G is 2 and L is 1, and you assign the values, for example, GGG is 2, 2, 2, then what is the sum of, let's say a certain syllable is given, and then you ask the sum according to if G is 2 and L is 1.
Srinandan?
Yes, sir.
Yeah. Can you state the question?
Yes, sir. In how many different ways can you add 2 and 1 to get 6? And the number of ways is inclusive of the order in which you have 2 and 1.
Can you repeat it slowly?
Yes, sir. So in how many ways, how many different ways can you add 2 and 1 to get 6? And the number of ways is inclusive of the order in which you add 2 and 1. So
We are
the
saying,
order matters.
yeah, this order is different from this order.
Yes, sir. Both of them are different.
Okay. Kirti?
Yes, sir. Is there any connection between these values and the row number?
Is there any connection between these values and the row number?
Something from these values and get the row number or something.
Good question. We'll see that in the next slide. Anushka?
Yes, so we can say that we have an equation 2x plus y where so g is 2, so x represents the number of g's and y represents the number of l's, and this 2x plus y should be equal to 6, and we have the condition that x and y are greater than equal to 0, and then after finding the values of x and y, we also need to permute. So because LG is different from GLLG, so permuting these number of cases.
So this is x is 3, then y is 0, x is 2, then y is 2, x is 1, then y is 4, x is 0, then y is 6. Right, Anushka?
Yeah.
Yeah, in this case, in this particular example, right? So this would mean that there are certain cases where you have 3 G's, yes. There are certain cases where you have 2 G's, yes, and maybe even more, and certain cases where you have 1 G and so on, right? Okay. So all of you said a lot of good things. I saw some messages on chat as well. So basically it is asking about how many numbers exist where the sum of the digits is 6 and you can use only the digits 1 and 2. How many numbers exist where you use the digits 1 and 2 and the sum of the digits is given? Okay. Pratyusha, clear?
Yes, sir.
Sharv, clear?
Yes, sir.
Karnam?
Yes, sir.
Sorry, say that again. No,
No, I understood.
you understood. All right. Okay. So naturally, the next questions are, can we have a prastara, a rule for listing this down? Can we have the sankhya, a process to find how many possibilities exist? Can we have a procedure for nashta? That is, we have made the prastara, right? And we lost it. We want to find the 15th row of, say, a 6 matra prastara. 6 matra means the total count is 6. Is there a way to find the 15th row, the nashta process? Can we have uddishta process? Somebody is saying, okay, this will come in which row? And can we have some kind of a meru, like matra meru, like the varna meru, what we saw as the so-called Pascal's triangle, right? So can we have some meru like this, and so on? That is what we are going to see. Okay, Kirti, this is what you are asking, right?
Yes, sir.
Right. Okay. We'll just take a quick look at how these combinatorics appeared in different texts, non-mathematical texts like Ayurveda. Okay, so there is a famous what we can say. I mean, I really don't want to put them under one box of doctors or medical practitioners or scientists, because they were all polymath. So Charaka writes a particular text. Charaka is the name of the author, called Sutrasthana. Charaka also wrote Charaka. No, that was Sushrusha. Okay. So Charaka in it is a text in Ayurveda, and then he says that Trishashti is 63. Okay. Vikalpas 63 possibilities. 63 with the Trishashti with the Vikalpa, that 63 different possibilities are there when you take 6 flavors. Okay, if you take 6 flavors of, say, perfumes or something, or 6 rasas basically over here, and if you mix 6 rasas, taking 1 at a time or 2 at a time or 3 at a time or 4 at a time or 5 at a time, you can get 63 possible combinations. 1, 2, 3, 4, 5, 6 rasas are there. You have 2 choices for each of them. You can take it or you can leave it. Those are the 2 choices. It's a binary problem. Counting principle says you can multiply all of them, you get 2 power 6. But of course, you cannot make rasa if you have rejected all of them. You cannot have a empty plate and say that, oh, taste this rasa. It looks wonderful. It tastes wonderful. So that one case we are reducing from this, that gives us 63. Okay, so we see appearance of combinatorics in Ayurveda, and this is how the verses go. These verses I'm just saying so that there is evidence. Otherwise, you'll say, oh, this guy is cooking up stories. So if somebody challenges, then there is a source and there are verses, and they can look up to that. This is how it says, choosing 2 from 6, we have 15 possibilities. Choosing 3 from 6, we have 20 possibilities. 6 choose 1, 6 choose 2, 6 choose 3, and so on. And then you add, this is what we get. So this is the thing that is explained. So at least it was known at that time. It's very clear. There is something called as Gandha Yukti in Varahamihira's text. Varahamihira was an astronomer, okay? He's 6th century astronomer. He is talking about perfumes in his text on astronomy. So fascinating, right? Who would expect that you will talk about perfumes in a text on astronomy, right? And for that matter, who would believe that we'll be dealing with poetry in a class of mathematics? So he was talking about choosing 4 perfumes from 16 flavors. Now, how many ways we can do that? He says there are 1820 ways, and the procedure for doing that he gives is very interesting. He gives, in fact, this procedure is explained by Bhattotpala. This procedure of how to do 16 choose 4. He says, write down 1 to 16 like this. Then you write 1 plus 2 is 3, 1 plus 2 plus 3 is 6, 1 plus 2 plus 3 plus 4 is this. You keep adding that and you go till the 15th row. You write 1, 1 plus 3, 4, 1 plus 3 plus 6, 10, 1 plus 3, this, and so on up to 500, up to 14th row. And then you do that up to the 13th row. So this is 1, 2, 3, 4 columns because we are doing 16, choose 4. This is 16, and then you do this. So this is going to be your value for 16, choose 4. It's a way to compute. It's a way to compute. Now, if you know a bit of complex, you will say, oh yeah, of course, it has to be this way. It's quite obvious, right? But that's because we know. All right. So let's come to Matra Vrittas. What are Matra Vrittas? Matra Vrittas, like I said, you assign values for Laghu as 1 and Guru. Okay. Matra essentially means a count. Of course, Matra also means punctuation. Matra means something else. So it's a technical term that we are using. In this context, it refers to count. So I'll put all these things, in the PPT, but you can go through this. These are quite interesting facts, from the history. All right. So let's look at how do you generate or how do you do a lot of writing. Okay. Let me just use this to write. Okay. So our first question is rule for Prastara. How do you list it down? Let's start with a small case. Let's say 4 Matra Prastara. 4 Matra. We want to list everything. You have to listen carefully. Don't write down anything. Just first listen and then try to do. Start with a row with all G's. Does that ring any bell? Have you heard this somewhere?
Yes.
Where?
Virahanka and
Virahanka.
Right? So start with a row with all G's. Scan from the left. Right? Below the first G, you put a L. Okay? Copy down whatever is there on the right side. If there are empty spaces on the left, this is where it changes. Okay? So if you are talking about Varnavritta, there are no empty spaces to the left. But in Matra Vritta, there are empty spaces over here because the total count should be 4. Now L plus G over here is 3, which means we need to add 1 more. So there is an empty space to the left. We will fill it up with a L. Now it becomes complete 4. Again, we scan from the left. Below the first G, we put a L. Now the total is 1. How many empty spaces? 3. What do you think is the problem now that you might be facing? Do a raise hand. I'll call out names. Akshay.
So now, what do you decide? Like whether 3 lagus or
Yeah, whether 3 lagus or Guru Laghu or Laghu Guru, right? Which one to choose? So there is no problem. What we do is, the rule says put as many G's, put as many G's as possible or required, okay, and place an L at the beginning if needed. not required, I'll say possible. And place an L at the beginning if needed. So what do you think should come here out of these three?
G.
Others, what do you think what should come here?
I think it should be LG.
LG, right? Because you place as many G's as possible. You can place only one G, and if required, you place a L. Again, you scan from the left. When you see the first G, you place a L below that. Copy down whatever is there on the right side. Sharv, what do you think will come on the left?
There should be a G.
G. Pratusha, continue.
So scan from the left, and
Hmm.
now we one L, then copy down what is there on the right hand side. Now we just require one, so we'll put an L in the beginning.
Srinandan, continue.
Sir, I'm not sure what to do now.
Akshat, continue.
Yes, sir. Sir, we copy down 2 L's at the start.
How? Why? What rule tells you that
So
you can do that?
we can stop.
Wait, are you Akshat? Are you Akshat? I'm asking Akshat.
Sir, actually, I'm not that sure, but maybe we stop here.
Why?
Not really sure, sir.
That's okay. That's okay. Karnam.
Sir, I think we should stop because in the rule it is said that that below G you have to place an L, but there is no G in the last one, so we can't place an L in the next one.
So we stop there because there is the rule says below the first G you place an L and you continue the process. And here there is no G. And if you remember the earlier rule, we had to stop when we encounter all L's.
Yeah.
Now, how many possibilities exist? We have 5 possibilities, 5 options for a 4 matra vritta. That means you are writing, let's say, a verse with 4 matras. You have 5 choices. You can choose any one of this. Okay. So this matra vritta or matra prastar, matra vritta actually is used in vernacular languages, for composition. Used in vernacular languages, and I think in Sanskrit also there is earlier part of Sanskrit that is classical Sanskrit, and there is I don't know what is the other Sanskrit that is called non-classical, let us say. Okay, so in that the second part we see matra vrittas used in construction. Okay, all right. So can you try? Yes, Arjun, question?
But why are there only 2 G's at the start instead of 4?
Because G equals 2 and L equals 1 in matra, right? Because we are giving a count. Is that clear, Arjun?
Oh, okay.
Meera?
Sir, is there any patterns between the number of rows between matras? Like there is a relationship between the number of rows in 2 matra
4 and 5, right? Like when we had 4 for Varna Vritta, we knew that the number of possibilities was 2 power 4. So there was a relationship. 4 and 5, is there a relationship? What you are asking? Good question.
Yeah.
We'll see. Devanand?
Sir, in this case, we started with 2 G's since it is a 4 matra prastara and we know that we should start with only G's. If it is a 3 matra prastara, then what would we use?
Right. So, or a 5 matra prastara, what do we do, right?
Yes.
So, let me ask you, what do you think should be the first row in the case of a 3 matra prastara?
Sir, it should contain 1 G and 1 L. Sir, will be LG or G?
So we go by
It's
this.
better to place L at the beginning, right? So it will be
Yeah.
LG.
So put as many G's as possible and place an L in the beginning if needed. So it will be LG. If it is 5, it will be LGG.
Okay, sir.
Okay. Shrutika?
Yes, so it doesn't matter like if it's just 2 LG or if it's 4 or 3 like, because in the before one there was like particular order, everything was like 4.
I didn't get you.
No, like before we had LG or else LLGG, but everything was 4 syllable. But here it's not like that. It can be 2.
Yeah. The number of syllables doesn't matter. The
Okay.
weight of the syllables matter.
Okay.
All right. So why don't you guys try out for 6 matra? Okay. 6 matra prastara. Do a 6 matra prastara. Send me the count on chat. Okay. Karnam, question?
Yes, sir. I have a comment that is, I think that.
Wait. No observations. No observations. If you have an observation, send it on chat right now. Okay.
Okay, sir.
So I want you to list 6 matra prastara. Tell me the final count on chat. Okay. How many did you get? Those who have sent me the answer so far, I'll request you to check again. Who have sent me the answer so far, check again. See, we write an L below the first G, okay, not below every G. And put as many G's as possible to the left, and if required, put a L.
So we start scanning from the right.
Sorry, say that again.
We start scanning from the right, right?
No, from the left.
Oh, okay, yeah.
Okay, don't give me the entire list. Some of you are sending the entire list on chat. I just want the count. Some of you are sending me the answers which are kind of, too low. Cannot be too low. I mean, how can the number of possibilities be as low as 6? Because when we are talking about 6 matra, it can be 4 laghus and 1 guru also. And in that we have that itself, we have 5 possibilities. Right? The answer cannot be 2 or 7. Okay, so let's do the listing, and maybe I'll call out some names who can help me get there. Simran, or wait, not Simran. Haim. Give me the first row, Haim.
First row will be 3G.
Where is your video? First row is
3Gs.
3Gs. Okay. Continue.
Then we scan from the left. So first G becomes L, LGG, and then we add an L to the left. Then once again, scan from the left. First G becomes L. So we get 4 L's and 1 G.
Day. If there are empty spaces, put as many G's as possible, and if required, place an L.
Okay, then.
And before that, you copy down whatever is there on the right side. Now, empty space, this is 3. We want 3 more. Aim, tell me how will you place the syllables? Sorry, say that again.
1 second, sir.
Put as many G's as possible and then place an L.
Okay.
Right? Yeah. Continue, Haim.
Scan from the left. So L, L, LG.
No. GLLG. This is the first G. Below that, you put an L. Copy down whatever is there on the right side. This count is now 4. You need a 6. Put as many G's as possible, and if required, you place an L. Next row, Haim.
Next row, the first G becomes L. So L, 2 L's and G. That's a total of 5. So we'd add 1 L to the left.
Next row.
Again, this time we only have 1 L at the end, and then we'll be adding 2 G's and 1 L.
1 L.
Same thing again. So G becomes L, first G. So we have LGL, and that would be 4. We'll add 1 L.
1 G.
Oh yeah, G, sorry. Yeah, then once more L and LGL, L, LGL, and we need to add an L now. Yeah. Then the G becomes L. So we have to write LL and 2 G's.
Simran, continue.
So first G will become L. Next GLL. And one more G.
One more G.
SB.
Total, look at the total.
Yes.
The total is 5. We need 6.
L to the
L.
G becomes L. Copy down the next. And 1 G here and 1 L. Next G becomes L. Copy down the and G here.
This is LL. Then you have a L. Right? So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 possibilities. 13 possibilities. Okay. Right. Is there anything interesting that you see in this and the earlier one? Earlier one that we had was, oops,
The numbers of syllables already got increasing in the fourth one, like in the fourth mantras this listing, but in the sixth mantras listing, the syllables also got decreased.
decreased,
The number of syllables.
increased, no?
Yeah, but the number, like after a 5 syllable, after a 5 syllable prastara, then we got 4th syllable too. The number, like the number of syllables are 4 and 5.
Okay, the number of syllables are 4, 5 for a 4 matra prasthana, like that.
No, I mean in 4th matra prastara, the number of syllables are like
Yes.
3 syllable, 3 syllable, and then 4th syllable, like that. But in 6th matra prastara, then the number of syllable was like.
I see. We are saying there are 2 and then 3 and then 4.
Yeah, that
Here
got
it
me
is
so confusing.
4, yeah. But here it is not the case because you have 5 and then 4.
Yeah.
Right. Good, good. Kashyap?
Yeah, so in the 6 matra prastara, the first 5 are the same as the 4 matra one, except there is a trailing G. So if you remove that G, it will be the same.
Okay, let
For
me
the
just
first-
try to color it. Saying, you look at this one, this yellow part, 1, 2, 3, 4, 5. Hey, 1, 2, 3, 4, 5 is this 1, 2, 3, 4, 5. GG, LLG, LGL, GLL, LLLL. Can you see there is a tailing G. Interesting. Very interesting.
Yeah.
Excellent observation, Ishan. Karnam.
For 4 we get 5 possibilities. For 6 we get 13. So I'm just guessing that for n matra prastaras we will get n plus 1th Fibonacci number, because
Really? How do you know all these things, Karnam?
sir, I just guessed it because 5 and 13 are in the sequence. That's all.
I see. Okay. Shresht?
I think we should just check the second and
But
fourth.
did Shresht change his voice? Shresht.
Yeah, same like him. I also thought it would be something related to the Fibonacci sequence when I saw the 5 and 13. But also like a comment on Ishan's observation of it being the same as the previous one. I think because in the start, the last G will not be used until all the previous ones are L's. So then it's kind of like you're ignoring the G until you get all L's in the left, left, right? So then it will.
I'm a little lost, Shresht.
Oh yeah. So he said that the first 5 are the same as the 4 matra prasthana, right?
Mm-hmm.
So then there's basically only one G at the right added, right?
Mm-hmm.
Of these, and by the rule, you will only change that G to to an L if there's no G behind it. Right?
There is no G behind it. What do you mean by B?
No, G behind it meaning all are L's, then there's only one G at the right at the end, right?
I guess
little
what
lost.
he's
Can you?
saying is like until otherwise we reach the last G, why are we going to change it? Because the G is
Yeah.
before that also.
Yeah.
Okay.
Like in the fourth one, there was a G, L, L, G, right? So you won't change the second G, you'll change the first G.
Mm-hmm.
So then that's why till you have all L, 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 G, then you won't change it. So that's why it's the same as the four matra prastara, the first 5. Because basically there's only one G at the right and the rest is the same till you reach L, 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 G.
Okay.
So I have one more observation. It's like similar to this. Like after the LLLG, All the other ones in the 6 matra prastara is basically the 5 matra prastara with the tailing L.
That's your conjecture. Okay, that's what Arjun is saying. Arushi also seems to nod her head on that. So let's find out. What these guys are saying is, look, the 5 matra prastara will be this.
Yeah.
Okay. What are you willing to bet on, Shrutika?
How much? Because I just wrote it down and figured it out.
Okay, so how much ever you want, right? So what will be the first row for a 4, 5
LG.
matra? Has to be LG, right? Scan from the left, below the first G put an L, copy down whatever is there on the right side. If there are empty spaces, put as many G's as you want or as possible. Then place an L if it is required. Again, scan from the left, below the first G, you place an L, copy down whatever is there on the right side. If
Add
put
an
as
L.
many G's as possible, you don't have space for G, so you put a L. Again, scan from the left, below the first G, you put a L. Place as many G's as possible to the left. If required, put an L. There is no need for an L. Below the first G, you put an L, copy down whatever is there on the right side. If there are empty spaces, put as many G's as possible. And then you place an L before that. Again, scan from the left. Below the first G, you put an L. And this is L. And L, 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 G, L, 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 L. 1, 2, 3, 4, 5, 6, 7, 8. And Sahi Jawab. This is
Yes.
right. So, as Karnam guessed, and as some of you also guessed, this is what we get, and we are placing a L at the end, right?
So does this imply that 5 matra and 6 matra will be the 7th matra with the tailing G and L?
Yeah, probably.
Probably.
So 5 and 6, if you place one below the other, why don't we find out, right? Why don't we find out?
Yeah.
So 7 matra, okay? 7 matra. 7 matra is going to be you have to be very careful when you list 7 matra, okay? So I see a lot of hands raised. I'll take questions if you have any. If it is answers, comments, you can lower your hands. I'll take questions. Meanwhile, everybody can list 7 matra prastara.
I
Arushi,
think
question?
this is also how Pingala came up with this idea.
So Pingala actually talks about matra vritta, but not in great detail. Matra vritta, this prastara and stuff came a little later.
We won't be able to combine them because here the weightage of them matters. Over there,
Let's try. The safest thing that you can do in experiments is, math experiments. Nothing is going to explode. So do that. Arushi, question or comment? Okay, Sresh.
Yeah, so it's kind of more of comment, so I don't know if it's appropriate right now, but
go ahead.
It reminds me of like Pingala's method, right? Where you're like adding a G or an L to the end of the previous ones. Like we did the same thing in Pingala's method. Of course, here it's different because the number and matras are different, but
I mean the G and L look similar.
Yeah. So then you're just adding G, 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 L, L, L to the previous. Yes, that's why, like I said, it would be Fibonacci sequence, right? Also.
Okay. We'll see. Janvi.
Yeah, so since we're at, like, let's say we're going to do an 8th matra prastara, we're going to just rewrite the 6th matra prastara and write a GG, trail it with the G in the end. That will be part of the 8th matra prastara. So can we like add different prastaras? Let's say we wanted a 7, so we can add 3 and 4. The prastaras 3 and 4 together in a row. So
why don't you try? 3 plus 4 is 7. So your question is, if we add the 3 matra prastara and 4 matra prastara, will we get the 7 matra prastara, right?
Yeah.
So 3 matra prastara, if you look at it, we had a count 3, or we did not do it, but it has 3. And 4 matra prastara has 5. So 3 plus 5 will be 8. And 7 has to be more than 13.
It'll be part of the 7 matra. So we can get like little.
I see.
So, but then that means
okay, wait. Yes,
4
Janvi,
plus 5 is not 6.
One second. Janvi, I think that makes sense. What you're saying is it will be part.
It will be few possibilities, yes. Just like So then you can get, like, even for 8 matra, you can rewrite the 6th one and you can get part of it. If
How will you get
tail it
the
with a
rest?
G. So that I think.
Maybe
So
you
for
can
that,
take the
this
rest
one is
from
there in
whatever
two
you get from
matra prastara,
subtracted.
there are two
Oh,
rows,
okay.
and
Wait.
in three matra prastara, there are 3 rows. We just got the number of rows in 4th matra prastara, then we have to add the number of 2 matra prastara and 3 matra prastara. We will get like that. In 4 matra prastara, there are 5 rows, and in 5th matra prastara, there are 8 rows. In 8th matra, in 6th matra prastara, there are 13 rows, which is the sum of a number of rows in 4th matra prastara and 5th matra prastara, and it goes on like that.
Okay.
Yeah. So you add the 2 numbers before the
Okay.
prastaras.
Sir,
You can
I
combine
think
both those prastaras.
One second. Let me hear out Janvi. Guys, let me hear out Arushi. Yes,
so
Arushi.
I think I have a proof that you will follow Fibonacci. I've sent you in the chat. Can you just check?
I will. Anushka.
Yes, sir. What she's saying about being a part of it, that will always be true, because we see that the 4th one is like the 2nd and 3rd, the 5th one is 3rd and 4th, and and the 7th one also comprises of 4th, 5th, 6th, all of them. So like the initial ones will all be a part of the later ones, but like they'll be a small part of it, not all of them.
For that, if you take the exactly one before, that will be exact. Like for example, for 7th, if you take 6 and 5, then you'll get it without.
Yeah, that's what I meant. So you can add the 2 before, the rows of the 2 numbers prior to the one you're
Yeah, that's
doing,
what
and then you get all the possibilities.
We are simply adding 1 and 2, right? Adding
say that
L
again.
and G would be adding L and G would be like adding 1 and 2 the previous one.
Yeah. Right. Okay. So contemplate on it for 30 seconds. Meanwhile, let me just read the comments. Arushi.
Yes, sir.
Yeah. So Arushi sent me this. Okay. I think you all should take a look at it.
So can you please zoom it in?
Is this better?
Yes, sir.
So let Fn denote how many n-digit positive integers with digits 1 and 2 not contain adjacent 2's. For example, f of 3 is 5. Since there are 5 integers, 5 such integers. F of 3 is 5. Oh, you mean total? Oh, so the number of digits in this is constant. Okay, and how many digits not contain adjacent 2's? Sorry, I didn't get what is this. F of 3 is 5. You have to, sorry, can you elaborate that, Arushi?
So
For
which
second
part?
line, the second line, for example, f of 3 is 5. Oh, you have to use 1 and 2, right?
Yeah.
Not contain 2 adjacent 2's. Okay, so you cannot have a 2 2 2 or a 2 2 1 or a 1 2 2.
Yeah.
Okay, so you remove that, and then how many are there? Okay, and then f of 1, f of 2, and f of 4. Compute them. All right, and then write down a formula for f of n minus 1 and f of n minus 2. So this also comes up with this relation that if you have.
So
I
it's
see.
a different problem, but the
Yeah.
relation is the same, and I
The
thought that was
relationship is the
interesting.
same.
Sir, how did she prove the thing?
So let me do one. Let me ask her to share this in the chat with everybody. Is that okay, Arushi?
Yes, sir, I'll do that.
Yeah. So everybody can take a look at it. And oh, it's 9 past 9. Okay, so right. So while Arushi does that, yes, Kirti, question.
Sir, I can't message everyone.
I figured
Now
out
you can.
as to
Now you
why
can.
it is the Fibonacci number, sir. As to what Karnam said.
You figured out why it is.
Yes, sir.
You cracked the Da Vinci code. Right? So, okay, can again videos on. You know, while we take a pause here, just try to think what must have happened. What must have happened between Pingala's time and Virahanka's time. This was given by Virahanka. Okay, this Matra Prastara and all this thing was given by Virahanka. Can you see that he is using almost the same idea as Pingala, right? And he is tweaking the algorithm. Of course, that algorithm for Varnavritta start scanning from the left was given by Virahanka. So he must have started off something like, all right, this is the listing given by Pingala. I have a different algorithm that will give you a row-wise listing of Varna Prastara, right? And when you do that, I also extend the problem to a Matra Prastara where you give a count of 1 and 2 to Guru and Lagu. And then what I do is I just use that, scan from the left, I tweak it a little bit. But then, as some of you said, you see a proof without words. I don't know if you have heard of this proof without words, where you don't write anything, you just represent things, and that is like a self-evident thing. So what I think it was Ishan who said in the beginning, and others contributed to that. This is your f of 4, and it gives you 5 number of possibilities. And then you have a f of 5, which gives you 8. And you add these two, you get 13, which is f of 6. So what you do is you list this down. You place a G after that because 4 plus 2 is 6 and G is 2. 5 plus 1 is 6. So you place a L and then you do this. So it is same recurrence relation, right? What we discussed about yesterday. If you know f of n minus 1, if you know f of n minus 2, copy and paste them one below the other. Place a G's below the first, to the right of the first part, then L's to the right of the second part, right? Now, what is the proof? The proof is you just look at it. That's how they gave the proof. See, it's so obvious. You look at it, and that's how you can say that it is definitely true. This thing was highlighted recently. We had a camp called Epsilon. It's a camp for 9 to 12-year-old students, and in that we had Professor Manjul Bhargava, the Fields medalist who presented a session. And in that he talks about this, and he says, the proof is, how did somebody asked, I think, how did they prove it? He said, the proof is just a 2-line proof. Copy and paste, and you put a G's below, to the right of the first part, and L to the right of the second part. Obvious proof, or proof by obviousness. All right, so we'll take a pause here. If you have quick questions, I'll be happy to take. But I have a meeting to attend immediately. So if there is nothing pressing, we'll take it up in the next session. If there is, feel free to stay back and ask. Sutika?
No, sir, I raised my hands before. So.
All right. Good, guys. I'm very happy with how you guys are observing and you are able to see and appreciate these ideas. That is amazing. But keep thinking about it. See what more can you come up with this, and any other observations if you are able to make after you do the listing. And if you have a whiteboard at home, you try to write down all these things. In our earlier home, me and my son, we used to do that in our bedroom wall. We used to write all math stuff on the wall. So it was all covered with numbers and other things. So you can do that at your own risk if your parents don't throw you out of home. But so you can, then you have all the patterns there, and then you can keep seeing that. Yes, Anushka?
So I was telling mine is recently printed, so no chance.
All right. See you guys. Bye.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Bye.